Good day everyone. Today, we will discuss about finding point estimates for population mean and population proportion. Before anything else, we will define first what is point estimate. Point estimate is a single value given as an estimate of a parameter of a population. There are two point estimates that we are going to use: population mean and population proportion.
The population mean is an average of a group characteristic. A population proportion is a fraction of the population that has certain characteristic.
The population mean is denoted as a mu, and the population proportion is denoted as a p.
Let's start. Now, we will compute the point estimate for population mean. Let's have an example. The mathematics 60-item exam results of all 54 students in grade 11 ARIS are the following. What is the population mean of all the scores?
So, in getting the population mean, you will only add all the results, and after getting the sum, you will divide it with the number of students. If you will add all those numbers, the answer is 2,563. Then divide it with 54 since there are 54 students in section ARIS, and the answer is 47.46. That is the population mean of the scores in section ARIS in the mathematics exam.
That's it for population mean. Now, let's discuss the point estimate for population proportion. This is more complex than getting the population mean. It has many steps. To deepen understand those steps, we will give an example. Suppose that 600 students and employees got randomly selected to get the vaccination against nCoV from a school population of 10,000. All 600 got exposed to the virus and 400 of them did not get the flu.
So now, we will state the given in the problem, and that is step 1. First, we have capital N for the total population of school, which is 10,000, small letter n for the number of trials, which is 600, and small letter r for the number of success, which is 400. Remember, the value of r is always smaller than the value of n.
So now, we will solve the sample proportion. The formula for sample proportion is P hat is equal to R over N. Substitute the values, it will now become like this. P hat is equal to 400 over 600, solve it. 400 divided 600 is equal to 0.67. Now, we will also get the number of failures which denoted by Q hat. The formula is Q hat is equal to 1 minus P hat. So we will substitute 1 minus 0.67, the answer is 0.33. That is our Q hat.
Now, we will proceed to step 2. There are 3 steps that we are going to test in the problems. These are randomness, normality, and independence. First step is randomness. As we go back to the problem, it is obviously past the randomness test. There's a word randomly selected in the problem, so it passed the randomness. Next is normality. There are 2 steps under normality, and these are n times p hat is greater than 10, n times q hat is greater than 10. If the answer agreed the formula, we can include that the distribution that we will going to use is z distribution. Let's substitute the values for n times p hat, which are 600 times 0.67. The answer is 402. So 402 is greater than 10. So it is very okay. What next?
Next is for n times q hat, which is 600 times 0.33. And the answer is 198. 198 is greater than 10, and that is very okay. So we pass the normality.
So, the next step is independence. The formula for independence is capital N is greater than or equal to 10 times small letter n. So let's substitute the 10 times small letter n, which is 600. So 10 times 600 is equal to 6,000. Then 10,000 is greater than 600, so we pass the independence.
Let's proceed in the third step, and that is getting the critical value. So there's a continuation to the problem. Find the marginal error at 99 confidence level denoted as C. So there's a table called the Z table showing the confidence level and corresponding critical values denoted as ZC. So we're only finding the ZC or the critical value of 99% and that is 2.58.
So let's proceed to step number 4, the confidence interval. So we will list down all the values that is needed in the equation, which are small letter n, which is 600, p hat, which is 0.67, then the q hat, which is 0.33, and the zc, which is 2.8. So now we will find the marginal error, denoted by E, with the formula is E is equal to square root of p hat times square root of q hat divided by square root of small letter n. Substitute all the values and solve it, and the answer will be 0.0495. So that is now our marginal error.
Now we will find the confidence interval. The formula is p hat minus e is less than p is less than p hat plus e. Substitute the values and solve. Then we will come up with 0.6205 is less than p is less than 0.7195. Let's convert the decimals into percentage, and this will become 62.05% is less than p is less than 71.95%.
In our problem, we are finding the percentage for the number of students and employees who are not exposed to nCoV. So, our final interpretation is, we are 99% confident that the probability of students and employees who are not exposed to nCoV is between 62.05% and 71.95%.
Point estimate is very important to us because we will definitely know the chances of having a problem, and it gives us accurate data and information about the current status of the phenomena.